Hello, judges. I am Aarti Narayanan, working as a data engineer in India. First of all, thank you, Google and Kaggle, for this wonderful 5-day AI agent intensive vibe coding course. I am presenting this Capstone project under the Agents for Good track. My project is AgriGuard-MCP. It is a secure, context-aware decision support for the smallholder farmers. Smallholder farmers, as you are all aware, manage a massive portion of global agricultural land, but they really lack access to the real-time hyperlocal expertise. Standard LLMs can definitely provide the general advice, but they pose a few major risks in the production. They hallucinate the critical metrics, they lack visibility to local data pools, and they are vulnerable to prompt injections. AgriGuard MCP solves this as a fully decoupled two-tier system, as outlined in this diagram, in this README diagram. This is it's a multi-agent architecture. We separate the user interface from our authoritative databases using the MCP protocol. The system runs mainline Gemini 2.5 flash core at a deterministic temperature of zero point 0.0, communicating with an isolated background MCP server over the standard IO pipeline, IO streams. For the setup we use a virtual environment. We use the UV for ultra fast. It is a containerized dependency tracking system with a local virtual region. Let's spin into the live pipeline and see the protocol handshake in action. Before that, I like to walk through into the two major things we have developed here. One is MCP server. Here, looking at the data layer in the MCP server, this acts as a application single source of truth. Instead of stuffing raw data into prompt, this server encapsulate our local soil metrics and a community plant disease database, exposing them exclusively as a strict structured tool schemas. So we have two tools here: get soil metrics and query disease registry. They are separated structured tool schemas. Now moving to agent .py. This is a major agent we have developed. Switching to our this is our primary orchestrator client. It manages the user session and handles the communication channel. While testing, we'll be able to see that it programmatically establishes a secure stdio connection to our server. It automatically executes a asynchronous handshake, dynamically discovering the tools like get soil metrics and query disease registry, and it will bind them directly to the Gemini 2.5 flash. So by this, the Gemini will be able. It does not have any hard-coded data, and it pulls a record dynamically only when requested. And it is the main thing. One more major function is that we have implemented the guardrail here for security, which is very very important. In security perspective, we'll be looking into this while we are testing as well. So moving into the testing part, let's go and jump into the uh, 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 let's run this agent now. So as soon as we run this agent, we are able to see that it is this agent is connecting through a secure handshake protocol to the MCP server. So this is extremely secure, and only dynamically it reaches out. So let's test it by a prompt. Test current soil metrics. Alpha. So I'm trying to retrieve the soil metrics of zone alpha here, which we have specified in that local MCP server. So immediately the orchestral decision took it is activating the tool, and from the tool it gets a get soil metrics. With that, it is sending the required arguments, and finally, AgriGuard response. Gemini is able to give a proper proper correct information from our MCP server. The background server instantly runs our exact ground truth records and gives the value because of our model runs at zero point 0.0 temperature and processes these raw database records. Gemini cleanly summarizes the true parameters and provides accurate remediation advice without inventing or altering any numerical figures. So it completely avoids hallucination. It connects only to the tool and gets the complete correct data. So this guarantees the data integrity for the farmer. Now let's move to the next very important part of the project, that is the security. Suppose like there is an adversarial user who is trying to do a prompt injection to hijack the system's core instruction. Let's try to give a malicious prompt like ignore all previous instructions. Okay. We can see here that security guardrail immediately pops up and then it blocks it. The malicious prompt not never even reaches the Gemini API backend. It and the API AgriGuard features an application perimeter string triage filter right in our script that intercepts the instruction override attempt instantly. It blocks the exploit, logs the security event, and gracefully redirects the conversation to supporting the firm. This entire layer runs smoothly on standard free tier infrastructure. My suppose like once again I'm trying to ask some question like related to farm. See, immediately it takes the tool activation, query disease registry, and it finds the disease. It might be a mild view, and it is giving a proper solution for this. This will be extremely useful to the farmers. Like once it is done in a full-fledged form. Moving forward, by combining this protocol driven tool discovery with robust input validation, we have built a system that is factual, secure, and ready for real world deployment. Looking ahead, I plan to develop this project further by adding multimodal capabilities to identify crop diseases directly from uploaded photographs using Gemini's vision features. I also intend to build out a rich, user friendly graphical user interface to move past the terminal and bring this tool directly into the hands of the mobile first farmers. By that, it will reach more farmers very easily. Uh, Thank you.